Good morning, everyone. Today we will be discussing supervised learning, model performance, and model selection. My name is Gaurav Saha, and I am presenting this on behalf of my team. So let's get started. So let's start with the agenda for today's presentation. I will cover introduction, key models, and first part of model evaluation, and my teammate Sanjay will cover the rest of the agendas, that is second half of the model evaluation and model selection. So let's get started. Introduction to supervised learning. So supervised learning is a machine learning approach where models are trained using labeled data to predict outcomes from unseen data. Types of supervised learning: we have regression, which predicts continuous values, example stock prices; classification, which predicts category labels, example fraud detection. So goal is to learn a function that maps inputs to an output based on training data. Key models. So let's see key models used in finance. First we have linear regression, which predicts continuous outcomes by modeling relationship between variables. Then we have logistic regression, which is used for binary classification problems. Then we have SRM or support vector machine, which maximizes the margin between classes, good for high dimensional data. Then we have k nearest neighbor or KNN, which classifies based on the distance to nearest training points. Then we have ensemble models, example random forest, gradient boosting, which combines multiple models to improve performance and reduces overfitting. Then we have regularization in supervised learning. So basically regularization help us to prevent overfitting by penalizing large coefficients. Let's see types of regularization. We have lasso or L1 regulation, which adds penalty equal to the absolute value of the magnitude of coefficient. You can see the example of formula. C ridge or L2 regularization, which adds a penalty equal to the square of the magnitude of coefficient. You can see the formula. So basically L1 regularization adds a penalty equal to the absolute value, whereas L2 regression adds a penalty equal to a square of the magnitude of the coefficient. So the benefits are it reduces model complexity, making it less prone to overfitting. And then we have ensemble methods in supervised learning. So it combines multiple models to improve overall performance. Some common ensemble techniques are bagging, which reduces variance by combining prediction from multiple models trained on different samples, example in the forest. Then we have boosting, which sequentially trains models with each new models correcting the errors of previous models, example gradient boosting. Then we have advantages of ensemble models. So the advantages are it basically improves accuracy and reduces overfitting and provides robustness. You can see the formula. Then we have model evaluation, overfitting versus underfitting. So overfitting is when the model learns noise in the training data, reducing generalizability, and underfitting when the model is too simple, failing to capture the data structure. So overfitting is when a model good performs well with training data but performs poorly with testing data. And underfitting is when the model performs poorly with both training and testing data. You can see the visual graph of underfitting and overfitting. Thank you.